Rotation of axis. In this video, we are going to derive the equations of rotation and equations of inverse rotation when a certain set of axes is rotated through a certain angle. Consider a set of axes and let P be a point on this plane. Note that this set of axes is represented by small letters small x and small y. So the coordinates of point P with respect to this system of axes is small x and small y. Now we rotate the system through a certain angle theta, and the rotated set of axes is represented by capital X, Y. So the coordinates of the same point P according to this new rotated axis are capital X and capital Y. We join O and P and label this length as R. We draw a perpendicular PM from P on small x-axis. The line OP makes an angle alpha with the small x-axis. Now in the right triangle OPM, OM is the base which is represented by small x and PM is the height or perpendicular which is represented by small y. These are the coordinates of point P according to the original set of axes small x-axis and small y-axis. Now in the right triangle OPM, cos alpha will be equal to base over hypotenuse and sine alpha will be equal to perpendicular over hypotenuse. That is, cos alpha will be small x over r and sine alpha will be equal to small y over small r. From here we get small x as r cos alpha and small y is equal to r sine alpha. Now we come to the rotated set of axes. The line OP makes an angle alpha minus theta with capital x-axis, which is a rotated position of small x-axis. We draw a perpendicular PN from P on capital x-axis. So OPN is a right triangle. In this right triangle, ON is the base which is represented by capital X and PN is the perpendicular which is represented by capital Y. The capital X and capital Y are the coordinates of the same point P according to the rotated set of axes. In this right triangle OPN, cos of alpha minus theta will be equal to capital X over R and sine of alpha minus theta will be equal to capital Y over R. From here we get the values of capital X and capital Y as capital X is equal to R cos alpha minus theta and capital Y is equal to R sine alpha minus theta. Now we expand cos alpha minus theta. So capital X will be equal to R into cos alpha cos theta plus sin alpha sin theta. Multiply R with both these terms and we get capital X is equal to R cos alpha cos theta plus R sin alpha sin theta. We have already proved that small x is equal to R cos alpha and small y is equal to R sin alpha. So replace these values and we get capital X is equal to x cos theta plus y sin theta. Rearrange it and write it as capital X is equal to cos theta x plus sin theta y. Now we take capital Y. Capital Y is equal to R sin alpha minus theta. Again we expand sin alpha minus theta as capital Y is equal to r into sine alpha cos theta minus cos alpha sine theta. Multiply r with both these terms and we get x is equal to r sine alpha cos theta minus r cos alpha sine theta. Again replace r sine alpha by y and r cos alpha by x and we get capital Y is equal to this. Rearrange it and write it as capital Y is equal to minus sine theta x plus cos theta y. So capital X is equal to cos theta x plus sine theta y and capital Y is equal to minus sine theta x plus cos theta y. These are equations of rotation. Now we find the equations of inverse rotation. We shall apply Cramer's rule to find the equations of inverse rotation. The equations of rotation can be arranged as, and in matrices form, these can be written as this. Now we apply Cramer's rule and find the values of small x and small y as small x will be equal to quotient of these two determinants. We evaluate these two determinants and get small x is equal to cos theta capital X minus sin theta capital Y. Similarly, we find small y as the quotient of these two determinants. We evaluate these two determinants and find the value of small y to be sin theta capital X plus cos theta capital Y. So small x is equal to cos theta capital X minus sin theta capital Y and small y is equal to sin theta capital X plus cos theta capital Y. These are equations of inverse rotation. Do remember that equations of rotation and equations of inverse rotation are simply a relationship between small xy and capital XY, that is coordinates of a point with respect to original axis and coordinates of the same point with respect to the rotated set of axes.